Hello students, there is a quick video on another apparent error in one of the questions asked in JEE Advanced 2025. The question is related to error estimation, and this is something which we can call blunder. The question says a single slit diffraction experiment is performed to determine the slit width using the equation BD by capital D is equal to m lambda, where B is slit width, D is shortest distance between the slit and the screen, D is the distance between mth diffraction maximum and the central maximum, and lambda is the wavelength. D and D are measured with, actually you need not know about all these things in order to solve this question. You may not have heard anything about diffraction and you can still solve this question. Basically the question says that there is a relationship BD by capital D is equal to m lambda. Using this relationship we are supposed to calculate B. M and lambda are known accurately. Capital D and small d are measured with a scale of least count 1 centimeter and 1 millimeter respectively. The values of lambda and small m are known precisely to be 600 nanometer and 3 respectively. The absolute error in the value of B estimated using the diffraction maximum that occurs for m is equal to 3 with D is equal to 5 mm and capital D is equal to 1 meter is. So basically the question says that you are trying to calculate a quantity B using this formula, where small m is a fixed number 3 and lambda is also a quantity that is having infinite number of significant digits. It is accurately known, its value is 600 nanometer. Capital D and small d are two measured quantities and they could have errors. So because capital D and small d are measured quantities and the values that we are assuming for capital D and small d may be carrying some error, therefore when you calculate small b, the error will propagate into it. So whatever value of B you are writing, it might carry error. So you are supposed to estimate that error. The absolute error in the value of B estimated using this formula will be. This is the actual arrangement. If you all know about diffraction, light is entering through a slit having width B and it gets diffracted. This is the intensity pattern. This is the central maximum, first diffraction maxima, secondary maxima actually, then second, then third. So from central maximum to third maximum the distance is D. This was measured. This separation capital D was measured. This was measured using a scale which has least count of 1 centimeter and the measured value is 100 centimeter. So the possible error or the maximum possible error in value of capital D is 1%. The maximum possible error that could be there in the value of capital D is 1 centimeter when the measured value is 100 centimeter. So the percentage wise the error is 1%. Okay, that is pretty small. But what about this small d? This small d was measured to be 5 mm and it was measured using a scale having least count of 1 mm. So the percentage error in measured value of small d could be as high as 20%. Oh, this by no imagination this can be considered to be a small error. It is a huge big error. So the normal formula that students learn for estimating error, I will write it down. The fractional error in B can be written as, these things are absolute constants. So you learn it like this, right? Delta D by D mod delta D by D, something like this. So using this formula is not appropriate in this case. This is approximately correct. This is approximately correct when the percentage errors in capital D and small d are small. For large errors, you just cannot use this expression, and the error in value of small d is as large as 20%. So this is ruled out. You cannot estimate it like this. So what do we need to do? We need to do the calculation. Okay, let us do it. So first I will use this formula to find the value of B. What is value of M? 3. What is value of lambda? 600 nanometer converted into meter. D is 1 meter. What is value of D? Though we do not know accurately, but our best judgment says that it is 1 meter, 100 centimeter. So we will assume that this is the best estimated value of D, and according to the experimenter, value of D is 1 meter. Similarly, value of small d is 5 millimeter converted into meter, 5 into 10 to the power minus 3. You do the necessary arithmetics and you get 360 micrometer. So this is the value of B according to the experimenter. But if you put a gun on his head and ask him, are you 100% sure that this is the value of B? Then he will say no. There could be error in this value, because the value of capital D and small d might be having errors. आपने कैपिटल डी को 1 मीटर माना है, वो एक्चुअली 1 मीटर 1 सेंटीमीटर हो सकता है या 99 सेंटीमीटर हो सकता है. सिमिलरली स्मॉल डी कैन बी एज हाई एज 6 मिलीमीटर एंड एज लो एज 4 मिलीमीटर. सो ऑब्वियसली हमने जो इसको 5 मिलीमीटर और इसको 1 मीटर मान के कैलकुलेशन किया, इट कुड बी रॉन्ग. सो लेट अस ट्राई टू अंडरस्टैंड व्हाट कुड बी लार्जेस्ट पॉसिबल वैल्यू ऑफ बी हियर. लार्जेस्ट पॉसिबल वैल्यू ऑफ बी, दैट मीन्स आपने ये बी की वैल्यू मान ली और रात को भगवान ने फ़ोन करके आपसे कहा हा 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 आपने बहुत सारे मिस्टेक किए, आपने जिस कैपिटल डी को 1 मीटर लिखा वो एक्चुअली 1.01 मीटर है, 101 सेंटीमीटर है. बैड डे, आज सुबह से दिन खराब है आपका. आपने जिसे 1 मीटर लिखा वो एक्चुअल में भगवान ने बताया 1.01 है. आपने जिसे 5 मिलीमीटर लिखा वो भगवान ने शाम को फ़ोन करके आपसे कहा कि 4 मिलीमीटर था वो. दैट मीन्स ये नंबर बड़ा से बड़ा आप कितना हो सकता है 1.01 मीटर, और ये नंबर छोटा से छोटा 4 मिलीमीटर. ये बड़ा से बड़ा और ये छोटा से छोटा, तो दिस विल गिव द मैक्सिमम पॉसिबल वैल्यू ऑफ बी. लेट मी कॉल इट एज B1. इफ यू डू द नेसेसरी अर्थमेटिक, इट इज़ अराउंड 450 माइक्रोमीटर. देख लीजिएगा, आई एम नॉट कैलकुलेटेड इट वेरी एक्यूरेटली. 450 माइक्रोमीटर. So in this case, if it is your bad day and your luck is not favoring you, you have taken value of capital D to be 1 meter, which is actually 1.01. You have taken value of small d to be 5 millimeter, which is actually 4 millimeter. In that case, the true value of B happens to be 450 micrometer, whereas you have calculated it as 360. So the error is this minus this. That is 90 micrometer. Take another scenario on the other side. B2. What about B2? B2, what is B2? The other bad day. Actually, what happened that you took capital D to be 1 meter, which was actually 0.99 meter. You took small d to be 5 millimeter, which was actually 6 millimeter. So the lowest possible value of numerator is this, and this is the highest possible value of denominator. So calculating this way, it will give you the minimum value of B. If you do the arithmetic, you get around 297 micrometer as the least possible value of B that is possible. But you have calculated it to be 360 micrometer. This is the least possible value of B. आपका बुरा दिन है. आपने जिसे 1 मीटर माना वो एक्चुअली 99 सेंटीमीटर है. आपने जिसे 5 मिलीमीटर माना वो एक्चुअली में 6 मिलीमीटर है. तो ऐसी सिचुएशन में B की जो सबसे छोटी वैल्यू हो सकती है वो 297 माइक्रोमीटर हो सकती है, और आप मान के चल रहे हैं 360 माइक्रोमीटर. तो इस केस में आपका एरर 63 माइक्रोमीटर का हो सकता है. पहले केस में 90 माइक्रोमीटर, दूसरे में 63. या इसको थोड़ा और देख लीजिएगा कैलकुलेट करके. क्वेश्चन में क्या पूछा है, देखते हैं हम कोई आंसर लिख सकते हैं क्या. द एब्सोल्यूट एरर इन द वैल्यू ऑफ बी एस्टिमेटेड यूजिंग द डिफ्रैक्शन मैक्सिमम दैट अकर्स फॉर m is equal to 3 with d is equal to 5 mm and capital D is equal to 1 meter is. सो एब्सोल्यूट एरर अगर हम ऐसे इसको समझें कि मैक्सिमम पॉसिबल एरर, हम बी की वैल्यू में मैक्सिमम पॉसिबल एरर क्या हो सकता है ये समझने की कोशिश कर रहे हैं. अगर मुझे एक ही नंबर रिपोर्ट करनी है तो आई विल से 90 माइक्रोमीटर. अदरवाइज एक्चुअली माय वैल्यू ऑफ बी विल बी 360 माइक्रोमीटर. ट्रू वैल्यू which can be as low as 297 and as high as 450. So actually I will say that B lies somewhere between 297 to 450 micrometer. Right, this is right way of expressing it given the data set. बट अगर एक ही नंबर आप मुझसे पूछेंगे तो ऑब्वियसली मैं मैक्सिमम पॉसिबल जो एरर हो सकता है वही बताऊंगा आपको, और उस केस में मैं एटलीस्ट इस क्वेश्चन का आंसर 90 माइक्रोमीटर लिख के आ जाता अगर मैं स्टूडेंट होता, एग्ज़ाम हॉल में बैठा हुआ। ठीक है, मिलते हैं अगले वीडियो में किसी और बातचीत के साथ। गुड बाय।